Hello folks on YouTube, this is KJ6EPL, and I'm going to explain to you how to do this amphibious mod to your JJRC H6D, as well as explain the math behind it for if you would like to do this to a different quadcopter. First, we'll start with how to do the mod. What you'll need is a standard ping pong ball, the little snap-on feet that have the two pegs on either side. I know a lot of people lose these, but we'll make use of these today. You will also need a 5/64 inch drill bit, because it just happens to be the right size to get these pegs to press into place. So it goes without saying, use the drill bit to make a hole in the ping pong ball. Then you take your little peg, stuff one of the pegs down into the hole, and I'm not going to really be able to do this for you because it takes some force to get it to go in, and I'm holding a camera with one hand. But after you do that, then you just take some super glue, put it around the outside of the little foot to permanently secure it to the ping pong ball. Okay folks, now I will describe the math behind how this works, so that way if you would like to make floats for a different quadcopter, you know how to calculate if your float will be sufficient to keep your quadcopter afloat. First, we'll start with Archimedes' principle, which states that the buoyancy force created by an object, such as this float, is equal to the weight of the water displaced by the object minus the weight of the object itself. We know that the density of water is 1 gram per cubic centimeter. So if we can find the volume of this sphere in cubic centimeters, we'll know how much weight in water this will displace. Now this obviously is a sphere, and all ping pong balls are 40 millimeters in diameter. We'll convert that to centimeters, which is simply 4 centimeters. The formula for a volume of a sphere is 4/3 times pi r cubed. So, we take our radius of 2 centimeters, cube it, plug it into that equation, and we get roughly 33.5 grams of force. The weight of this little guy, wait for my scale to turn on, okay, we're looking at 2.6 grams. So it's precisely about 31 something, but we'll just keep it simple and say that the buoyancy force provided by each ping pong ball is 30 grams. Times 4 ping pong balls, you have 120 grams of buoyancy force. Now, our quadcopter here, zero the thing. Okay, and mind you, I've got an extended capacity battery in this, so the factory battery, it'll probably a gram or two less, but you can see our quadcopter actually only weighs 51 grams. So we have almost a little more than twice the actual buoyancy force needed to safely float this quadcopter. And you will need more than the minimum, because remember, as your quadcopter lands, especially if you're a rookie pilot and haven't figured out soft landings yet, there will be an extra impact when your quadcopter hits the ground. It turns out that these floats are adequate, having just done the buoyancy test video. Now, another little quick tip here that I forgot to mention, you may notice the wire sticking up from the frame here. Little bonus content. This is a range extension mod. Simply drill a little hole in your canopy here, extend the antenna vertically, and that will significantly increase the range of your quadcopter. Well, I hope you have fun,